Find the gradient of the normal to the curve. So we know that normal, it's a line which is perpendicular to the gradient, and if two lines are perpendicular, the gradient of one is negative reciprocal of another, and we also know that gradient of a tangent is derivative at the point where it is drawn. So we can find the gradient of a tangent at point 1, 2 firstly, and then we can find the gradient of a normal as negative reciprocal. So we need to consider the derivative, and since we can see it is not represented as y is, so we should apply an implicit differentiation. So we just differentiate both sides, and here we can see a product, so we apply product rule, and it becomes 3x squared derivative, it's 6x multiplied by just y, plus 3x squared and y derivative. Y is a function of x, so we apply a chain rule and it becomes dy dx, plus 2x derivative, it's 2y squared, plus 2x y squared derivative, it's 2y dy dx, so it's finally 4x y dy dx is 0 because 2 derivative is 0. And we need dy dx, so when we solve for dy dx, dy dx becomes, we move negative 2y squared to the right as negative 2y squared, and also 6xy to the right, and to the left we get dy, we can factor out dy dx, and in parentheses we get 3x squared plus 4xy, and then divide both sides by 3x squared plus 4xy, we get an expression for dy dx. And we need at a point, so dy dx at 1, negative 2 becomes, just substitute 1 for x, negative 2 for y, and get negative 2 squared times 4 minus 6, 1 times negative 2 over 3 times 1 plus 4 times 1 times negative 2, which is negative 8 plus 12, 3 minus 8, so it's 4 over negative 5. It's gradient over tangent, hence gradient over normal is negative reciprocal, it means opposite sign and flipped, so it's 5 over 4. And it's not needed here, but in general, if you need an equation of a normal, it becomes y is 5 over 4x plus c, and you just substitute negative 2 for y and 1 for x and solve for c, and hence you get an equation of a normal. So the required gradient over normal is 5 over 4, and the solve for this question.